Okay, so as we've seen, we're dealing with variables. And these variables are, the x in this case is standing for, any name can take any name. And the names we've been looking at are the lowercase letters at the beginning of the alphabet. And if we need more names, of course, we can introduce subscripts, A1, A2, A3, etc. Okay, so we won't run out of names. And we're going to look right now at how we can move from these general claims to particular claims about objects or names. Okay. And that move is called instantiation. And we have two kinds of instantiation that we'll be working with. We've got universal instantiation, and we saw one example of that already. And existential instantiation. Which we haven't seen yet, but we'll introduce now. Universal instantiation is the simpler of the two. And universal instantiation basically says, of course it applies to the universal quantifier, these guys, that when the universal quantifier is the main logical operator in a formula, we can instantiate the variable that it has scope over to any name. So what do I mean by that? Well, up here, the variable that's being bound here by the quantifier is the x. And the x that falls within the scope of the quantifier, and scope, as you saw in the text, just means, what it has syntactical control of, you might say. Okay, so this is the x we're talking about here. And it says, for all x, fx and gx, by universal instantiation, we can replace the x's with any name, drop the quantifier, and come out with a statement like the following: fj and gj. So here, let's say it's friendly and gregarious. So Jan is friendly and Jan is gregarious. Okay, well, how could you know that Jan is friendly and Jan is gregarious? I know that because by universal instantiation, I was able to conclude from the premise that it is the case. Now, how were you able to do that? Well, your premise was all things are friendly and gregarious. For any x you pick, x is friendly and gregarious. Therefore, you know you can replace the x with any name and validly conclude that Jan is friendly and Jan is gregarious. Now notice here that the main logical operator at this point is the and. And of course then we can conclude by simplification fj. Okay, so we know that Jan is friendly. Or gj, we know that Jan is gregarious. So by universal instantiation, we move to this sentence, this formula, and then by simplification, we were able to conclude these two lines. So universal instantiation, again, allows you to drop the universal quantifier and replace the variables with any name whatsoever. And this will prove very important as you go forward. Now let's say, before we talk about existential instantiation, let's take, for example, our old friend, love. So now, let's take a look at this, and let's apply our rule of universal instantiation and then see what we can do from there. Okay, so again, this reads, everyone loves someone. So now let's say we're interested in George and who George loves and what George is up to. We can validly move, since the main logical operator here is the, for all x, the universal quantifier, we can validly move by instantiation to the following. Okay, so we got from here to here by universal instantiation. We're going to label it UI for short, and we'll say UI from line, and then we'll label the source in the direct proof. So UI from line 1, let's say. Let's call this line 1, and this is line 2. So what have we got here? Now we've got a claim that says there is some y such that George loves y. Now, can we conclude from that anything about the identity of the person that George loves? Actually, we can't, right? All we know is that George loves someone, and we don't know anything further about the identity of his beloved. Okay? So when we're dealing with an existential quantifier, we're not able to move from the existentially quantified variable to a specific name, like Maud or Harry or Fido. We're stuck with someone. Okay, I hope that's clear. So once again, when we have the universal quantifier, we can, and when it's the main logical operator, it's safe to go ahead and universally instantiate to whatever name you'd like. Now, existential instantiation is a lot more, it's tricky, right? Because let's say, for example, you know that someone is a burglar. Let's say you said, someone in this class is a burglar. Well, you know that at least one person in this class is a burglar, and you can reason about the burglar. So for example, you could say someone is a burglar and that person is a criminal, right? So someone's a burglar and he or she or they are a criminal. Okay, it could be more than one person. Maybe everyone in the class is a burglar. That's possible. So remember, some doesn't exclude all. So it might be the case that they're all burglars, we don't know. All we know is that someone is a burglar. It would be unfair to jump from the statement that someone is a burglar to the statement that, you know, Fido is a burglar or Samantha is a burglar. Okay. So what do we do then with these existentially quantified statements? Well, for example, if you have, there's some x, dx, where d is dead. Here, let's say from detective stories, you know that sometimes you know that someone is dead because they're right there in front of you, but you don't know who they are. So what do you call them? You call them John Doe or Jane Doe. Okay, so what's the function of Jane Doe or John Doe in this context? Well, we say that John Doe, I guess it's a capital D, functions as a dummy name. Okay, a dummy name, meaning something like a placeholder so that you can continue to reason about the person you're talking about. You know you're talking about someone, but you don't know that person's identity. So the dummy name is going to be the thing to which we existentially instantiate. So we can't instantiate to a name that's appeared anywhere in the proof so far. That's going to be critically important. When we have the existentially quantified statement, we can't existentially instantiate to a name or a variable or anything that's appeared previously in the statement or in the proof, right? And we've got to use something like a dummy name. And so what we'll do is in the examples that we give in the short videos and in the text, you'll be able to find some strategies for performing these existential instantiations and how strategically they can be used in a proof. Okay, so remember, you've got maximum flexibility with universal instantiation. You've got very little flexibility with existential instantiation. But let's take, for example, our burglar in the class. Let's say we were to say someone in this class is a burglar, right? And let's say, for example, we said everyone in this class will pass the class. Okay? We can conclude that since everyone in the class will pass the class, that the burglar will pass the class. So now if we think about the order of instantiation here, strategically, it's good to wait until you've taken care of all of your existential instantiations before you start universally instantiating where possible, right? Because you want to be able to reason to, for example, everyone in this class will pass the class. There is some burglar in the class. 2, the burglar is going to pass the class. You want to be able to do that, but let's say you existentially instantiated to, I don't know, John. And you said, someone in the class, or someone in this class is a burglar. Everyone in this class will pass the class. Therefore, John will pass the class. You certainly don't want to accuse me of being the burglar in any shape or form. So hold off on your universal instantiations. If you want to say something about burglars, make sure you don't say something about John or Jane or Fido, etc., etc. So do your existential instantiations where possible before you do your universal instantiations. And in the short videos, I'll try to give you some additional strategies and some bookkeeping techniques for keeping track of these things so that you won't inadvertently accuse me or Fido or Jane of being the burglar. Okay.